Yes, we're going to put the fun back in function. Man, I like that one. That's good. All right. We're going to talk about functions. Functions save us so much time. Okay. It's not quite object-oriented, but it's kind of a little bit. So we're going to cover a whole bunch of stuff in here. We're going to talk about how to implement them. We're going to talk about how parameters are passed, what we can do with them. We're going to demonstrate scope of variables. Learn how to think recursively, not requiring you to write a recursive program. I was like, that was a nightmare.
It was a nightmare.
Okay.
Spent like 5 hours on it.
That's all?
All day, yeah. And then if it was this year, it would.
All right, functions, they say, as black boxes. An example of that is, okay, I got a Chevy Volt car. It's an electric car. I climb in and I push the start button. Then I drive. Do I know how the car actually functions? I have no clue. For a lot of people, they have no clue. Like a shifter on the floor, a lot of people don't know what that does. The point is, do I need to know how my car functions? No, I just know that I need to know the basics of it, how to start it, how to stop it, how to control it. But do I need to know, like, what percentage it switches from battery to gas or how this works and all that other stuff? No, I don't need to know that. So that's the cool thing about functions. You can make it do something, and the people that use your functions, it's like, have we used random in here yet? Yeah. Yeah, we've
done examples.
We did something with random. Do we need to know how Python handles random? No, we don't need to know how to do it. I've read a couple different books about casinos, and they were talking about all these people figure out how random number generators work and actually win at casinos because of it. Because there is no such thing as random. It's really based upon something. It's kind of like if I was to ask you to choose a number, and just randomly pick a number between 1 and 10. Do you think you could do that? No, because whatever you choose is going to be based upon something. Maybe it's your favorite number, or maybe you're picking not your favorite number because the other one is your favorite number. So in other words, you're basing your randomness upon something. But in other words, we don't know exactly how it works, and we don't care as long as we can use it. Okay, make sense? That's what functions are. Okay. It's a sequence of instructions with a name. We need to be able to call it, just like random, just like print, just like input. Do you know how input actually works? How does it actually get characters from the keyboard into the computer system? I don't know. We don't need to know. We just need to know how to use it. Okay, so that's what we're talking about here. So here they talk about rounding and stuff like that. Okay, calling functions. See if we make this just a little bit bigger. I don't want to make it full screen because then I can't do anything else on the screen. Let's move this over. Okay. So in this example here, we're calling the function called round, and we're passing it some values. We're passing in a number and the precision, or the number of decimal places we want. And it returns a number. In this case, it returns 6.83. Easy. Do we need to know how it does it? No. We just need to know how to use it. Okay. So far, so good? Okay. Here's what they're talking about it, how it works. But, we don't really need to know how it works in general. It just takes it and returns a value to us. Now, the way we know this one returns a value to us is we have our function, and it actually price is equal to that. So that function is going to do something and return the value into price. Okay, easy enough. Nothing special there. We've actually done some of this stuff already. Okay. This says some functions require inputs. Now they talk about arguments. Now, depending on which languages you are working with, it's like Java, they're called functions. Or methods. Is Java called methods? But some programming language call them functions, some of them call them methods. The big difference is functions return a value, methods do not. But in Python, a function is both. So, I mean, if you ever hear the word functions or method, depending on your language, they could mean two different things. In Python, functions is all function. I mean, it's literally returns a value or not. It doesn't matter. Okay. But functions, a lot of time, will take an argument. It's like we call print. Print takes an argument. We pass it something. We pass it a string. We pass it a number. We pass it something, then it does, and it prints it. It's like, remember we used format last time. Some of you used it successfully, some of you did not. So we used the format function, which took our number, and depending on what we put inside the parentheses, it made it put out the comma, made it put out 2 decimal places. So those would be arguments passed to our function. So far, so good? Everybody here? No one's lost yet? Okay. It can receive multiple arguments, or they can receive no arguments. Can we use print, passing it one argument? Or how about no arguments?
Yeah.
Yeah, we can. Oh, you know what? Speaking of that, I want to show you how to fix something real quick. Okay, you know how when you open up idle, it always goes to that weird directory under some place? I got tired of that, so I fixed mine yesterday. Here's how you fix it. I brought up here, and I'm going to right-hand click on idle. I'm going to go to properties. Actually, I'm going to go to, seriously? Okay, it's in, I need to go to this directory. Well, there it is, open file location. Let me show you again in case you want to do this to yours. Right click on Python, go to properties, then right here it'll say open file location. And when you open it, it should, I'm going to change this, and I'm going to go over here to, come on. Can't do it on this machine? Seriously? Hold on. We still don't, we're missing something. Hold on, I gotta find something. That's what I want. I want that idle. Yeah, let me show. Okay, don't do it the way I was showing you initially.
Oh boy, now I'm just.
Sorry. Well, I mean, it's because I have it pinned on the taskbar. I'm typing idle, so it shows me the idle program right there. Now I'm going to right-hand click on that and do open file location. Still, it's not. Why is it not showing it to me? Seriously? They got these machines messed up. Well, that sucks. I want to be able to fix it. Stay right there a second. Yeah, mine works perfectly downstairs.
Whenever I open the file location, it just takes me to that folder you're on right now.
Yeah, but we should be able to find the idle program itself, the idle batch file. Where the heck is it? I don't know why it doesn't. Mine goes right to it in my office. Go to tools, maybe? Or maybe I can't show you on this one. That just really sucks. Where the heck is idle located? Maybe lib? Go back. It's got to be in here somewhere.
If you go to lib, it'll be idle lib.
Yeah, lib, idle dot PYW.
Okay, so lib, idle lib, and then there it is, idle PYW. Now I'm going to do properties of this one. You still don't have it though. Hey, there should be an open in. Where is the open in? Why don't they? Still, there's something weird on this one. I know they take away some of our capabilities. I'm wondering if they, because you should be able to tell it to open in a specific folder. Well, might have to tell you forget it.
Is that open with?
So there's folder path. No, it shouldn't be. Yeah, so we don't have the ability to change that. So open with tells it what program to open with. Well, that sucks. Yeah, oh well, forget that idea. I'm not gonna show you. I'll have to find out what they did something weird on these. On mine, I literally right-clicked on it, went to properties, change the folder I want to open in. It's good to go. Okay, sorry about that. Okay, so they can't receive multiple arguments or no arguments. So I'm going to bring up idle now. And I'm just going to type, once it loads, I'm just going to type print. And it literally just prints a blank line. So that's print with no arguments. Okay? I can also type print with a 5. And it prints a 5. I can type 2 arguments. 5 comma 2. And I can even do 5 comma high. So you can give it different combination of arguments, different types. So really, print is kind of nice. It's actually called overloading because it's the same function that can do multiple different things. It's set up to take no arguments or 1 argument or more arguments. Okay? Easy enough there. Shrink this down a little bit. All right, return values. We already talked about this a little bit, but a function can return a value. And the way you return a value is a return statement, which we will be doing, okay? And your homework assignment is going to require you to do that as well. But I will definitely show that to you. It says, do not confuse returning a value that produces a program output, which is produced with a print statement. Now, just because it does something does not necessarily mean it's returning a value. For instance, I called print. Print did something. It did not return a value to me. It just printed it on the screen. And we're going to see the difference. Function can return a value or not. Okay? And in other languages, it's called method or function. But here it's all called functions. Okay. Black box analogy. A thermostat is a black box. You set the desired temperature. It turns it on as required. You don't need to know how it works. Okay. Easy enough there. They would ever back, I don't know if they do this anymore. Back when I went to school, they gave us a thermostat with no markings on it. And we had to put it in boiling water and mark the 212. We had to put it in ice and mark the 0 or the 32. Then we had to make all the degrees between it. And we had to figure out how to make a thermostat, a thermometer. You guys don't do that anymore? No. Do you guys at least dissect stuff still?
It's too expensive for schools nowadays.
Yeah.
Not in my class.
Too expensive. When I went to school, all stuff was provided. I brought nothing. My son was getting distracted a lot in class, wasn't paying attention. So I went in there to sit behind him one day. He didn't like that behavior, just so you know. But I went in there. The entire back and entire side of the room was a wall of tissue paper, like Kleenex. Mm-hmm. It's like, why are we bringing Kleenex when literally the entire wall was boxes? It was like Lego blocks of tissue paper, Kleenex. It's like, what that? But maybe you don't have any money. That's crazy. They have fundraisers every other 5 minutes. I like the one, our students eat healthy. You have to sell donuts every day. Okay, but again, black box, we don't need to know how they work. We just need to know how to use them. Okay, easy enough there. Says the round function is a block box. We give it something and it rounds it. Do I care how? Does it truncate it? Does it round it? We don't care. It just returns a value that we use. Okay. Easy enough there. Says you may wonder how the rounding function does its job. It says the user of the function. You don't need to know how it does it. You just need to know how to use it. But there's always buts involved. But sometimes isn't it nice to know how things work? It's like when I was writing my John the Ripper program, there was some stuff I could not get Python to do. Like there's a function called toggle case, which y'all are going to play with. Then there's uppercase, and there's lowercase, and all those other ones. But I wanted to change it. I do camel case or every other letter. So I had to write my own function to do something like that because the built-in functions were not available to me. So sometimes you want to do something that just not there. Like maybe you want round to round differently. Like, did you ever take a number, like say the number is, 6.5. Well, actually, does Python support floor? Does anybody know? Let's look. Let's try it.
The double slash?
No. Let's see. Print floor. I don't know if this does this. Let's see. 5.8. It does not. Okay, some languages support floor.
Oh, that's when the late friends.
Right, it'll take 5.8 and make it a 5. Yes.
I believe it's double slash for that.
Oh, double slash, that will create an integer, won't it? That'll integerize it. It'll
Search it up.
truncate.
The floor division operator is the double slash.
Okay, then what's the ceiling one? In other words, 5.2 becomes 6. There's floor and then there's ceiling.
It's not dot floor.
Oh, it is math.floor? Okay, let's try that one.
Yeah, it's like, isn't that a
You're gonna have to import
function
that.
that?
And then you can do math.seal for the other one.
Okay, print. Okay, there's our math.floor. Now we're going to do the ceil, C-E-I-L. There you go. Okay, so it is there. It's just not, it's part of the math class. See, in this case, let me bring it up so I can see it. It wasn't, it's part of Python, but it's not really part of Python. If it was really built in without any importing required, we could have just typed floor and ceil. Kind of like print. We don't have to tell the class that print belongs to. But it is still there, so someone wrote it for us. So yeah, floor and ceil. They don't really round or truncate. They kind of either go to the bottom or the top. So there's an example of, some different functions for you. Okay. Designing your own. This is the best part. You all will be designing your own in your next assignment, which we're going to look at. Now, do they all have to be written exactly the same? No, as long as they produce the same output. Okay. I grade so many programming projects for so many different classes, and I was funny when a student, turns in work they copy off the internet. Well, there's only one way to write it. Someone already did it, so I just used it. I'm like, no, there's always more than one way to write everything. It's kind of like getting from my house to here. Is there only one way to get here? No, there's a million ways to get here. Okay. Okay, implementing and testing functions. Okay. Here they're working with queues. Okay. Actually, you know what? Let's make a function real quick. I want to make math.floor. We're going to make it ourselves. So I'm going to open up a brand new file here, file new. I'm going to call it whatever today's date is, which is the 24th. And we're going to save it on my desktop, my Python directory. Call it SEP. It's 24 SEP 2018. .py. So there we go. Now, we know we can import math and use math.floor. We just saw that. Y'all agree with that statement there? Well, we want to make our own. So what I'm going to do is I'm going to define with DEF a function called floor. The colon. Okay. Now, what is math.floor doing? It's doing the integer division. Is that correct? So in this case, I'm going to say return. Now, obviously, there's an argument. It's going to take a number. I'll just call it num. Return num. And I can't, that's integer division. I don't want to divide with anything. So how can I write a function to return just the 5? It's harder when you think about it, doesn't it? I can't just do / num, can I? I don't think I can. Don't think that'll work. No, I can't do that. So that's integer division. Let's just try this, see if it's working. Now, to run this, I'm going to call floor. I'm going to say print floor, and we'll do 5.2. All right, I'll show you what all this does. Okay, what this is, here I defined my own function called floor. It took an argument, and just like our if statements and our whiles, we always need a colon. Then we indent. Now inside here, we could do all kinds of stuff. We could actually, couldn't we do, what is, do we have to import for round or is round part built in?
I think it's built in.
Let's try that. Round, yep, it is. Num, comma, 0. Let's try that. 5.0. So it did round it, but returned me a decimal.
So you could put, yeah.
There we go. Okay. What I did was I declared a method called floor, a function called floor, receiving an argument. I told it to return something. Now, I said return the rounding of the number to 0 decimal places, and then convert it to an integer. So what it does, it's going to take that, whatever it receives, in this case is 5.2, convert it to a 5. Everybody see that? I could have done other stuff in here as well. I could have done, int, my or equals round. Could have done that. And then I could have done int. Could have done it many different ways. No. Can I do that? Oh, because it's already defined. There you go. I could do that. So the point is, you can make these functions any way you want. You can make them do something. You can have multiple lines in there. You can have a single line in there. And when it actually does get interpreted, it's going to end up being the same code, most likely anyway. All right, so kind of understand so far, kind of an example of creating one. That's not the only one we're going to do. Okay. So in their example here, they're defining a function called cube volume. So it says, want to create the volume of a cube. What does it need to do its job? What does it answer with when writing or defining the function? Pick a name that kind of means something. In this case, cube volume. Declare a variable called side-length. Put all the information together with the defined keyword, just like they did there. Okay. You run a test program according to the function definition. When nothing happens, after all, no one is calling the function. So what they're saying there is, say I commented this line out. Not that one's wrong key, sorry. I commented this one out. So when I run this, what did I get?
5, just didn't print it.
Really didn't even get 5. Because I commented out this line to pretend this line no longer exists. What I did was I defined a function. I never called a function. I never told it to do anything. I just defined something. Okay. All right. So let's type in their example so we can make sure it works. It's good example. Good practice here. Define cube volume side length. Move it over a little bit so we can actually see it. Vol equal side. All right, so I wrote that. Now I'm going to run this. It didn't do anything. The reason it didn't do anything is I just defined the function. I didn't tell it to do anything. I mean, I defined it. I'm just not using it yet. So here we're going to say results 1 equals cube volume. We're going to pass it a 2. I'm going to run it again. Side length is not defined. Did I spell it wrong? Yep. Side length. Side length. Okay. So again, it still did nothing. That's okay, because I really didn't tell it to do anything yet. So I'm going to copy this line, put a 10 in here. Now I'm going to say print a cube with the side 2 has a volume of, is that what they're typing? Has a volume. They don't have the of. Results 1. Okay, there's what they typed right there. Has result 1. Cube with side length 2 has a volume. I don't like the way they did that, but we're going to stick with it for the moment. And now it's going to be results 2, and we're going to put 10 over here. So now when I run it, results 2 is not defined. That's because I didn't change it up here. 2 has an 8, and a 10 has 1,000. Anybody get that? Or did I do something wrong? Anyone got that one yet?
Yeah.
Other than Summer, since she's busy not doing it.
Yeah, it's okay.
So, okay. So what did this actually do? Let's look at this code here. So this top section, notice how it didn't give me an error initially with my spelling error? So I just defined something. It really didn't know what was happening, so it didn't even do anything with it. So now we get down to our code. Before you can call a function, now this is very important when working with functions. You cannot call a function until you've already defined a function. Watch, let me show you what I mean by that. Say I take this line, move it up to the top.
You can't have anonymous functions.
Not yet. And it should have crashed. It should have said, got it. You can have global stuff like that, but still it has to be defined first. Which is kind of like the old Python, not Python, Pascal was. You had to define it first. So I can't call cube volume because it's not been defined yet. Okay? So once it's defined, then you can call it. Okay? Have to define it before you can use it. Make sense? Easy enough? Okay. So now when I run it, I get my results. Maybe. Yep, right there. Okay. So here we call cube volume passing it a 2. So that 2 gets accepted into our function as an argument, the value of 2. Then the volume is equal to the side length, which is, in this case, 2. What the heck is this thing? Anybody know what that means?
Yeah.
Double asterisks?
To the power of.
Exponents. So it's 2 raised to the 3rd power. Now, I'm pretty sure there's also a math class called POW.
Yeah.
There should be, which we could have used. Should be math.pow, and you pass it a number, comma 3. You could have done it either way, would it be acceptable? Then, so that's stored inside a volume, and then we return volume. Now, the next line does the same thing, but this time passing it a 10. So if you notice, now we can keep calling it over and over and over. We do not have to write the function over and over. Function is written one time. Okay. How can we make that function a little bit shorter? Anybody? Come on, someone's got to be able to see that.
You can return the. I mean, you don't have to define the volume before you.
Exactly. I can literally just do that. So what did that do for me by doing that? Shorten it a little bit. And think about anytime you define a variable in any language, think of like an Excel spreadsheet. It takes up another block in your spreadsheet and stores a value in it. Not a big deal for us, where we have one variable. But if you have thousands of variables and all this, I mean, one line of code could make a difference. Go watch Apollo 13 and see what I'm talking about. Love the movie. Okay. So we're good there. And another thing I don't like about this program, you see how we have the 2's hard-coded and the 10's hard-coded?
Yeah.
I don't like that. What you could have done actually is taken this, instead of saving the results, just put it right there. Okay? And take this one right here, and now mine's hard to see because I have big font.
You don't even have to do that. You can pass,
I can pass the
you can pass
variable too.
multiple variables in one call
So now these are no longer needed.
for multiple arguments of variables.
Oh, what did I do wrong? Did I spell something wrong?
Around the-
Oh, no, it did it. We're down here.
You need to close your window.
Yeah, I got too much junk on my window. Let's run it again. That worked beautifully. Okay. You can, like he said, you can pass multiple arguments, have it do it twice. There's lots of different ways you can make this work. Okay. So don't think there's only one way to do anything. I like writing code, and I kind of like to look at it afterwards and try to make it better. It's like, I'm assuming, when y'all do your homework, you literally sit down and write the entire thing, submit it, and be done with it.
No.
You probably work on it for a while.
Depending on the size of it.
But it also depends. It was something simple. Also, like when I was, I've taken many classes in my day. What I always try to do is at least have my assignment due a day early. That way you can just don't submit it and then wait, and then you'll look at it one more time. Especially when I was working on my PhD classes, you're working on research papers, and you want to be able to go over it one more time because there's always something in there that's wrong. But the code can be written anyway. Okay? So there's just an example. Okay, function definition, or the function header they call it, starts with DEF for define, has a function name, then it has the parentheses and the different arguments. Okay, there can be one or more. Then a colon. And then we have our function body, which does all its stuff, and it might have a return statement, might not. In this case, it did. Okay. Now, if you notice what I wrote it here, since I got rid of these two lines, did it actually return anything? Sure, it returned it and just printed it. It didn't return it into a variable and then print the variable. It just, while we're in the middle of printing that line, it's executing that print line. It calls the function, gets the result, and outputs it. It again saves on variable space. Okay. All right, so there's the definition. Programming tip: use comments. Normally, you would say, what's the input to the function? What's the output or the return of the function? That way you know. But again, when we're working on something this small, it's not a big deal. But in the real world, that'll make a really, really, really big difference. If you watch some of my other recordings, I talk about a guy, when I was taking one of my programming classes, they were saying, this guy was hired by this company as a programmer, and he worked there for a full year, did all this work for them, did not put a single comment in his code. And then when he quit, the code was considered worthless because there were no comments. They actually went to court, the company won, and he had to pay back every penny they ever paid him because they've shown that his software was worth zero. So if you don't know how it works, so comments are important. Again, this is an easy function here. But as they get more complex, I had a student here, Kyle Cook, who used to work down the hall in the lab. He got a job at Air Inc., which is over on the south side of Tinker. He was a programmer for them. Well, then he left and went to Tulsa and now went to work for the NSA. But then Frank Woodall got a job there after him. Frank used to work here as well. Frank got a job there. It was funny because Frank printed out the piece of code one day. Just one section of code. We had no earthly idea what this, there was no comments. It was like the most obfuscated code you've ever seen in your life. So we contacted Kyle and we're like, what did you do?
The other part is a lot of times your comments are they harvest the comments to print into the manuals.
Yes,
and
they do. Very much. That's where a lot of manuals come from. But we asked Kyle what that code did. He goes, oh, he knew Frank was getting the job there. So right before he left, he wrote this one function and made it as absolutely confusing as possible. It basically did nothing. but the way he wrote it. But yeah, William's exactly correct. We'll take these comments out. Think about it. If we write this, we know what it does. But do you think us as programmers write the manual? No. It's some other person.
A technical writer usually who has
Right.
no idea.
Yeah, right. A prime example is there's a movie I watched about a guy. You ever buy like IKEA furniture? You get that bookshelf that's in 300 pieces in a box and you got to assemble the darn thing. Most of the time when those are built, they just build the shelf. Then provide all the parts to somebody who then goes and figures out how to put it all together. He had no idea what they were thinking when they built it. That's why sometimes those instructions are stupid. So, he's making the instructions based on what he could figure out, yet they're not always correct. So comments are nice because at least you know when the program was writing it, at least what he thought. What was the input? What was the output? Now, hopefully what it does, and this is simple, but when I worked at Tinker, every file had the comments at the top. And these files could be thousands long. Every time we did something, we'd add more comments at the top. You always append it to this thing. You have your comment, the very top, it's called the prologue. You would have, the date, who did it, what they did, and you never deleted someone else. That way you can see the change, you can see the history of it. And whenever you change code, you never deleted it. Always commented it out, replaced it with a new code. That way you could always refer back to what people did. Because if you screw something up, I'll tell you, when I was in Tulsa working on my final compiler project, it was about maybe 5,000 or 7,000 lines, but it was really long. I was literally making backups of it hourly, stored offsite. So it was so long, I was so close to being finished. Anytime I make a little progress, I save it. I'd FTP it up to another location under a different name. Then because you don't want to have to go back and recreate the darn wheel. So the comments are important. So here it is with documentation. The thing at the top, very handy. Some of you, like William, writes amazing comments. Some of you,
You get fired in jobs if you, seriously, that's a major part of getting a job with somebody and retaining a job is how well you commented on your previous job. You have to bring your code to them and show them.
because every piece of code you write is probably going to be printed out. Literally, all of our code, we had 2 copies electronically, and we have a printed out copy. And like he's saying, they look at this stuff and can they understand it? Can they follow it?
It's almost secondary how good a program. I'm kind of a shitty programmer, but if I can figure out what I'm doing and then build a comment on it that a normal person can understand, that's more important to most bosses than.
Look at these comments here. This program computes the volume of 2 cubes. That's easy enough. I think all of us could understand. Computes the volume of the cube. It talks about the perimeter side length, the length of the side of the cube, and returns the volume of the cube. Doesn't tell exactly how it works. What I normally tell people is if you have 10 lines of code, you should at least have a comment. There's got to be something in that 10 lines that has to be explained. Okay. All right, cubes.py, we're not going to walk through it. We kind of wrote our own. Now they talk about the main function here. The reason they go with main in this book is because a lot of, like C and Java, they all start with main. So you don't have to call it main. They're just trying to stick with something. That way it might carry over to another language with you. Okay? So in this case, they call a main function. The main function where it starts, and you don't have to call it main, but you can. Okay? And you see here, their main function at the top. The function inside of that function calls another function. Because you can have one function that calls another function, and that function calls another function. You have many functions calling each other's functions. Okay? So in this case, their main calls cube volume 2 into results, prints that out. So when we ran it with main, we called main, which then called cube volume, which got the results, printed the results, okay? And the results from cube volume came from here, so easy enough to follow. Is everybody totally lost? Now, after grading some of y'all's work, I realize some of you are totally lost. But speak up. I mean, it's all I can do to help you. All right. Order says it's important to define any function before you call it. I already mentioned that. You must define it first. It drives me crazy because a lot of languages, you don't have to do that anymore. Java, you don't have to do that. The reason is Java is a compiled language. It goes through the entire bit of code, compiles it into bytecode, and then you execute that.
That's not the same for with that example. It was the main function called the
Oh, you're right.
called the cube volume, but the cube volume is defined after.
Why did that? That one shouldn't have worked. That should not work.
Like I've seen that work before, like in Java.
Let's write this thing. That's a good idea. I'm glad you brought that up. Darn it, we really need to.
Maybe that's an example of what not to do.
Yeah, I mean, it should not work. Define main. You don't have to write the whole thing. And okay, print.
That's not gonna work unless you pass the
Yeah.
secondary function through the main function.
Oh, hold on. We'll do main down here. So this will call main. Main will call cube volume. Cube volume should return it. Let's see if this works. It shouldn't. But darn, it does. Why? Wait, let me think. So main was defined. Why does that work?
Oh, I see what you're passing cube volume as a function or as part of the variable. When you
Right,
when you
with
go to print result, that's where you're calling it from. You're passing results.
Oh, yeah, it's already defined at
You're
that point.
grabbing cube volume, putting it in result, and then passing cube volume through result, and then with
Since
the
main
argument.
is after it, it's already called that. So that's it's kind of screwy the way that works, but it does. But normally, define everything at the top. See, when we got, so we could not call main before we defined main. But since we got down to call main, we had already both at that point had defined the two functions.
Needs comments.
Yeah,
Definitely.
because I've seen that work in Java, so I wasn't really throwing much of that off.
But Java, you
since
can
it
do
was-
that.
Since you were saying that.
Yeah, in Java you can because it compiles it. This is an interpreter. It starts at line 1. So if I was to take this main and move it here, it won't function. It's like, I don't know what main is. But since main was at the bottom, it line by line read the defined main, so it basically interpreted that function, then it interpreted the next one, then it got to main. At that point, it knew about the two functions, is why it worked. Okay? But if I put that ahead of time, it wouldn't have got there. It's just a little different that way. Again, it's one of those little things about different languages. Okay, so order matters. We just talked about that. You have to define it before you call it. Says, however, a function call from another function before the function has been defined is pretty legal. We just talked about that. That's literally what we just talked about. Okay, parameter passing. Says parameter values received as argument values applied in a function call. We can pass a to. We can pass a string. We can pass a literal, like an integer. We can actually pass another function to a function. Like, let's do that real quick here. So I could pass, did I do that? No, yeah, well, I don't know. I'm trying to figure out a way to rewrite that. I'm not going to bother. But you can pass a literal value like a 2. A 2 is called a literal. It's also called a constant. The reason it's called a constant is the number 2 is a 2. You all agree with that? What's it going to be tomorrow? Still going to be a 2. The 2 will never change. Now, if I had a variable like name, name could be changed. Okay. So I could pass a literal. I could pass a variable. I could even pass another function. The final project for my compiler project in Tulsa, I had to be able to handle a code that called a function and passed a function to itself, of itself. It was kind of like a recursive call, but it was passing a function to a function, and the function I passed to it was itself. It was weird the way we had to write this thing. But it was a good way of testing it. See if it handled recursion, see if it handled function passing, see if it handled argument passing, see if it handles everything. So it says a parameter value is declared in the function. It's initialized to it. We're going to talk about scope here in just a second. You can also call it a formal parameter.
So in everybody else can ignore this, but in Python, do you have to deal with callbacks? I mean, the way it threads, can you run a thread while, can you run your program while a thread is operating and then have that?
That's a good
callback?
question, because I don't know the answer to that yet. We were actually working on that on a program downstairs.
And like Node and Java and all
Yeah,
the
Java you can
C drive
do threads, no
callbacks.
problem. There's got to be a way. We literally last week we were just starting to play with that. I don't know if Jared's figured it out. But what he's talking about is, can you do this and this at the same time? Can you walk and chew gum at the same time? Okay? Or do you have to walk and then chew your gum and then walk some more and then chew? Can you
determine
literally
the result? Can the function be running in the background while the rest of your program? I mean, until the solution to the function is determined, can
Yeah.
the rest of the program keep running? And then when the function determines it, will it call back to the rest of the program?
When I went out to Tulsa, I wrote my first network sniffer program. I had to write a program that would capture network traffic off the network, and depending on what it was, it did something. So I wrote my code, so I basically read the traffic. When I received the traffic, I analyzed the traffic, then output the results. Makes sense. Y'all agree with that? There was a problem. So I read the traffic, then while I was analyzing, guess what was happening? More traffic was cruising around the network I was missing because I was busy analyzing. Then I was busy outputting the results. So I had to do, like he was saying, I had to write a threaded program. So literally one thread continually listened to traffic. That's all it did. Just listen to traffic. Then another one checked to see if there was some traffic to be analyzed. So it kept analyzing the entire time. As long as there was traffic to be analyzed, it would analyze it. Then the other one would output the results if there was something that was already been analyzed. So I had three different things doing stuff and returning values, and they're each dependent upon each other.
Some languages call them like event handlers or event listeners or whatever.
I don't know if this supports it. We literally were trying to do that last week. So I'll see if he's got it done. So. All right. So here we got the 2. So in this example, we passed 2 to cube volume. So the 2 gets passed down to the cube volume function. It's received into the variable called side length. Then side length is, multiply times 3. Then we get the volume. Then return the volume. That return value of volume gets passed back up to results 1 at the top. Okay. So it's trying to modify parameter variables. Now, if you change something inside of a function, in their example here, they have total is equal to 10. Okay. Then they're going to add some text, do something to it, and then return the value. Okay. But you can't, there's something called scope, which we're going to cover. That actually, I'm going to do that. You don't need to type this one. Okay, I'm going to do this here. I'm going to say, total equals 5. I'm going to say, I'm going to pass it total. I'm going to say print total. Here I'm going to say print total as well. Up here, so we're going to receive I'm just going to do return. Okay. So I set total to be a 5 right here. Then I'm printing the 5. It should print 5. Then I'm calling my main function, passing it total, which is 5. And then I'm printing out total again. Now, but up in here inside my main, I received the 5. Then I'm incrementing 5 to become 6. So what am I going to print here? Is it going to be 5 or 6? Anybody? Should be 5, unless I'm wrong.
No.
Can't do that? I thought we could do that. Seriously?
That stumped me for a whole weekend.
What about plus plus?
It's misspelled.
Wrong.
Oh, was that what it is? I spelled it wrong?
No, you
Oh,
spelled that one right.
Total.
So it prints the total, but then it doesn't print after you call main.
Oh, wait a minute. Duh, my bad. I didn't want to print this. I just wanted that. Okay, so it prints 5, 5. Okay, so what the heck is it? Y'all agree it just printed 5, 5?
Is it really not an iterator function?
No, and it sucks. I love, no, you can't.
That's
I know, it sucks. Why? I don't know why. Get a hold of, what's his face? You know, a guy wrote this on a Christmas vacation when he was bored. So I want a language to do something, and I'll look at it. It's going crazy. Okay. So I signed a 5 to total. So I printed out the 5. That's the first 5 I got. Then I called main, passing it total, which is 5. So up here I received 5. Then total is now equal to total plus 1. So total is now equal to 5 plus 1. So this total becomes 6. Okay? And I'll even add a print statement up here. Then spell it correctly. So now what should my output be? Anybody?
565.
565, exactly. 565. Because up here I added 1 to it, so it becomes 6. That prints out 6. But since I'm not returning the value,
Oh, I see what you mean.
okay, total down here, so this total is actually being defined. So I could have called it total 2 for all I care. I could have called it total 2, total 2, total 2. It's a totally different variable. Close this window out. Let me see if I can see it. So it's a totally different variable. This right here is an argument for main. It says, I'm receiving a new value into this variable. So it's defining total 2 at this point. I could call it total. I could call it total 2. I could call it cat. It doesn't matter. But I'm defining a new variable at that point, and the scope of that variable is local to that function.
I'm sorry to, will you try putting the plus in front of the equals? Because it's telling me that you can.
I know, I had it working the other day. I don't know why it didn't work. So that
I'll put a
should work.
1, yeah.
I don't know why this time, Aaron. I swear that didn't work a minute ago. But you can't do plus plus.
Maybe it's because you did the print.
Yeah. Because earlier you did the print from parentheses and.
Oh, I have that inside print? That's why.
Yeah.
Okay, that makes sense. My bad.
it's a
Yeah, I couldn't do that
print
inside the
statement.
print. But you cannot do plus plus. Plus plus is not part of this. All right.
Can't you just make a function that does it for you?
Actually, you could, yes. You could overload the plus sign.
If you're going to build that class, also build the class that allows you to do, what was the other thing that we were,
The print.
Threaded? Nah, threaded is very much.
No, it was something super simple. I'll remember it. Never mind.
And there's someone probably already wrote one. You can include it. But way back when I used to write a lot of different software, I'd make a Ken's Utils class, basically. Then I would keep throwing all my stuff in there. Every time I wrote something, I'm going to put it in there. Then I would include it in every program I wrote. And I could just call it. Because like way back then, like with ASP.NET, which is web language, but there was no pad left or pad right. Like I wanted to be able to pad something to a certain width, then either left or right or right. We can do it in Python, but we couldn't in ASP back then. So I used to write all that stuff, or pad center. And, okay, so I know some of you are like, what the hell are you talking about? That's all right. It'll be fine. Okay, so it really doesn't change the value as we just showed you. It's local to that function.
It's like the same as in like the for statements. Or like
Yes, it's
for,
inside there, yes. You can't use it outside. Return value, optional. You can return something, but you don't have to. In this last example, I'm not returning anything. I'm just printing something. This one here is returning. This one here is printing. So you don't have to return something. In other languages, That's the difference between function and method. Okay. You can have multiple return statements. You can return, that's weird. Some languages won't allow this, but this one does. So depending if side length is less than 0, obviously you cannot have a negative length, whatever. So if it's less than 0, you return 0, or else you return the length times 3. Okay, easy enough there? So you can return multiple things. But if you write your code so you can never get to the other return, it'll error out and say unreachable statement or something like that. I don't know a good example to show it to you, but you could have one. And there's an example. So if side length is greater than or equal to 0, multiply, or else return a 0. So you can't have multiple ones. Make sure a return catches all cases. You want your return statement to handle everything. What if it's a negative number? What if it's a positive number? What if it's equal to 0? What if it's equal to whatever? Tell you, one of the hardest things you ever program is null. N-U-L-L. Null is not nothing. It's null. It's not a 0. It's not nothing. And depending on languages, they handle them very differently. And sometimes it's just weird. It's not an empty string. It's just null. All right. So yeah, make sure you catch all cases. And that's pretty much what we just talked about. Let's move on to the next section. There's the code. Okay. Function without return once, that's what we just talked about. That's a function with no return statement. It just does something. In this case, it's printing something.
I remember some part of Java would get like mad at you if you didn't have a return statement in certain.
Yes. If you, well, it's like in C, I'm pretty sure C has to have a return statement every time.
Yeah, you do.
Yeah, but you can return 0 or something.
Oh, okay.
But again, it really depends on the language. Because that's one thing that they all vary on. It's like, oh. Okay. Actually, you know what? I want to pick up on slide 43 next time. We're not leaving because I want to talk about your next program. Okay. So we're going to start on 43. That way, if you want to start working on it, you have already learned everything you need to know to do it. So I'm going to stop this, start it again.